Hello guys, this is Dr. D back again, and we are talking about platelet. All right. Platelets are called thrombocytes. And again, we are looking at hemopoiesis or hematopoiesis. Start out with hemocytoblast and forms what? Myeloid and lymphoid cells. The myeloid cells can, under the influence of, again, a colony stimulating factor, in this case a hormone-like substance called thrombopoietin, will form megakaryoblast, megakaryocyte, which will fragment and break up into small pieces of cytoplasm. And basically that is what a platelet is, chunks of cytoplasm. Do they have a nucleus? No. They're way smaller than RBC. Do they have organelle? Absolutely not. So what is their function? Their function is to stick to damaged surface, form a temporary plug, release serotonin that will signal the smooth muscle cells to contract. Do you want to bleed to death once you cut? No. So it will signal the muscle cells to contract, and then it'll release enzymes which are important for clotting. These are the three functions. You have to know these. Okay, so we come across another word called hemostasis. Stasis means stop. So hemo means stopping of blood flow. Of course, when do you want that? You want that to stop bleeding, right? To stoppage of bleeding when the blood vessels are damaged. So there are three steps, and you need to know the sequence. First is blood vessel spasm, which is nothing but constriction. So here what happens is that the smooth muscle cells in the blood walls contract. You don't want blood flowing into that particular part which is damaged, and you are having blood flow, right? Platelet plug. So the platelets are going to stick together. They're going to stick together to the blood vessels, particularly to the collagen, and they will release serotonin as they clump together and form like a band-aid. They will also release serotonin, which will stimulate what? Vasoconstriction, right? Remember, that was the function of the platelet, right? All right. Now, blood coagulation involves there are two pathways. It's like a cascade effect. And what happens is the chain reaction. So once it is started, it will not stop until the entire process is complete. That's why we say that this is a okay. So here we'll talk about extrinsic clotting and intrinsic clotting. There are two chains reactions. So you will see that as we come across, you will see that there are factors. What are these factors? These factors are proteins. All right, and you do not need to know the pathway of the extrinsic or the intrinsic pathway. The only thing is extrinsic pathway is triggered when there's tissue damage, and intrinsic pathway is triggered when the blood contacts foreign surfaces. All right, but either case, you are going to form a prothrombin activator. You have to know this, and the prothrombin activator converts prothrombin into thrombin. Thrombin is going to convert the fibrinogen, which is soluble fiber in the plasma, into fibers called the fibrin. And these fibers are the ones that are going to now encase the platelet plug and entrap the RBC, which will form the clot. All right. So once again, do you need to know the entire sequence? No. You need to know that the clotting, this clotting mechanism, there are two pathways, extrinsic and intrinsic. All right. The intrinsic is longer pathway, involves more factors or clotting factors. The extrinsic is shorter, involves fewer factors. But by the way, intrinsic is the norm, is the default pathway. The extrinsic just will augment, supplement the intrinsic pathway. Either case, our main goal is to form what? Fibrin. So here, whatever pathway that follows here, you will have to know that prothrombin is converted into thrombin, which will stimulate conversion of fibrinogen into fibrin. And what is fibrin? Fibrin will form the fibers or the clot. All right. All right. So here you can, this is basically a repetition, but what I need to tell you is that this pathway clotting is a positive feedback. We do not stop until it is entire complete. All right. So once the stimulus is provided, then the entire pathway will complete itself. That is called a positive feedback pathway. All right. Now here, if there is, do you want excessive clotting? No. How do you control? So control is that, remember, the blood vessel lining and the blood cells naturally produce antithrombin. All right. Because if you have thrombin, fibrinogen will convert into fibrin. Fibrinogen is the soluble fibers. Fibrin is the insoluble fibers. All right. Now here also don't forget that the basophils as well as the blood vessel lining produce prostaglandin. What's prostaglandin? Inhibit binding of the platelets. All right. So also, I'm sorry, basophils also produce heparin. What's heparin? Heparin is an anticoagulant. So let me go back. The lining blood vessels produce prostaglandin. The basophils produce what? Heparin. All right, so always there's a balance between clot and inhibition. You will form the clot when you need to, right? And you'll inhibit the clot when you don't need to. So here, couple of things that I need to tell you. Vitamin K is absolutely necessary. Why? This is required for the correct folding of the clotting factors, because what are clotting factors? Proteins. So if you don't have vitamin K, will the clotting factors fold and therefore functional? Answer is no. And that's why deficiency of vitamin K results in bleeding issues. All right. Now here's more description of intrinsic and extrinsic pathway. Intrinsic pathway is activated when blood comes in contact with what? Subendothelial connective tissues or with foreign surfaces. All right. So it's the most important. Slower pathway. Now there are additional factors. Do you need to know these names? Answer is no. Extrinsic is an alternative pathway. Very rapid. But remember, it is extrinsic. It is triggered from the outside, but it is there to only augment the intrinsic pathway. All right. Now, clot dissolution is important, right? You are not going to walk around for the rest of your life with a clot. So, clot dissolution requires a protein called what? Plasminogen. Again, an activator which is released from the damaged tissues is going to convert plasminogen into plasmin. And what's plasmin? It's an enzyme. Enzyme that is going to dissolve the what? The blood clot. All right. So obviously this information is important, especially if you are going to dissolve some unnecessary or not needed clots, especially after heart attacks or strokes, right? So after strokes, some kind of drugs are given that will activate the plasminogen activator or will convert or form plasmin. And examples are TPase or streptokinase or urokinase. All right. All right. So here, this is the summary of platelet function, which you can go over. So what are the abnormal clots? One is the thrombi and one is the embolus. Thrombi is the clot formation within a blood vessel. It is stationary. Embolus is when the clot breaks away and starts moving with the blood flow. Which one do you think is more dangerous? Obviously embolus, because once it goes to your brain, it's going to block those blood vessels, and what do you end up with? You'll end up with a stroke, right? So here, bleeding and blood clotting disorders. Now here, hemophilia is a bleeding disorder, and this is again a genetic disorder. It's an X-linked recessive pattern, and there are two types of hemophilia, A and B. So males will exhibit full-blown disease, and usually the females are carriers. All right. So what does it result from? Deficiency of what? Clotting factors, which are what? proteins, all right? Thrombocytopenia is platelet deficiency. There is increased breakdown of the platelets. By the way, the platelets have a lifespan of how many days? Only 10 days, 10 to 12 days, all right? That's not more than that. So they may occur because of what? Bone marrow or cancer. And also there are some drugs which interfere with clotting, which we talked about. These are blood thinners. Aspirin is a good blood thinner. I've heard of ginkgo, never heard of warfarin, ibuprofen. These are blood thinners. So if you have blood clotting problem, well, don't take these. All right, so with this we come to our end of our presentation for the white blood cells. And if there are questions or concerns, please come and see me or please contact me. I thank you for your patience of listening to my presentation. Thank you. Have a great day.